Macromolecules are just very large molecules, macro obviously meaning large. But even more specifically, they are polymers. The word polymer refers to a single repeating chain of multiple subunits. Poly means many, mers meaning units. Effectively, they're just long chains, and each unit in that chain is known as a monomer, where mono means single or one. But while each monomer has its own function, and each polymer has its own unique function, it's important to talk about how polymers can be assembled from these monomers. The way it's done is through a chemical reaction, and normally in biology, most of our chemical reactions are synthesized or facilitated by enzymes. Enzymes act as catalysts. And what the word catalyst really means is anything that speeds up a reaction. So the use of these macromolecules is usually facilitated by enzymes. However, there are two main types of reactions we have to talk about, which are synthesis reactions and decomposition reactions. In synthesis reactions, we see one molecule being formed from two or more subunits that come together and form a bond to create that molecule. In decomposition, we see the reverse process. One molecule splits into its units. In the case of polymers, we see this through water. Water is the universal unit for any polymer reaction. In fact, the two types of reactions that specifically apply to polymers, for synthesis, it's called a condensation, or also commonly dehydration reaction. We know what these terms mean. They're referring to the removal of water, whereas in decomposition, we have hydrolysis. Think about it. Hydrolysis. Hydro and lysis. Hydro meaning water, lysis meaning breakage. So a dehydration reaction works through the mechanism of removing water to form a bond. Basically, if I have molecule A here, and let's say at the very end I have a hydrogen atom, and I have molecule B here, and at the very end I have a hydroxyl group, which you'll remember from our lesson on functional units. If this hydrogen and this hydroxyl will interact to form a water molecule, and that water molecule is removed, what's formed then is a new bond that connects these two. This is how we can chain multiple monomers like A and B to create a polymer, AB. But there's also the inverse process, where if you have already bonded A to B, and you force in a water droplet or a water molecule, then these molecules will tack on the hydrogen and hydroxyl groups respectively, and that bond will be broken. This is the basic process for synthesis and decomposition of polymers. The most vital concept about polymers and what leads to their massive diversity is going to be a very simple idea. Let's say we have monomers A, B, and C. How many polymers can we make from this set of three monomers? Well, if you said one, the answer is a lot more complicated than you might expect. First, remember that we can take any combination of these two, so AB, BC, or AC, and these are all valid polymers. Also, remember that if we don't want to use just two polymers, or two monomers, sorry, we can use three, giving us combinations like ABC, and that's about it. ABC is the only valid combination we can get from here, right? But not actually. In fact, the order of these monomers can cause completely different polymers to be formed. Monomers A, B, and C, in this order, ABC, will have a massively different function from something like BAC. And it's the reason that even from a set of, let's say, 20 monomers, you can create an absolutely outrageous number of polymers. That's a super important concept we need to know, because it explains why there's so much diversity in the molecules in our body, even if these are the only starting monomers we have.